So welcome to the latest episode of Absolutely Zero Knowledge, and we're going to dive straight in, and I'm welcomed by Teemu from Gevulot. So do you want to head straight in and introduce yourself and tell us a little bit more about you?
Sure, yeah. So my name's Teemu Päivinen. It's a tricky name to pronounce.
I'm glad I didn't do it.
Yeah. I'm from Finland. I'm the founder and CEO of Gevulot, which is a decentralized proving layer for the modular stack. Yeah.
And I guess bit of background about you personally, and we'll touch upon sort of where Gevulot has come from. But what's your background then, and where have you come from, and how did you get into the world of ZKP?
Well, it's a long or a short story depending on how I tell it. But so maybe in general, my background is I've essentially been an entrepreneur in the blockchain space since about 2012. I started a Bitcoin exchange back then here in Europe or in the Nordics, but we were operating across a whole bunch of countries in Europe called CoinMotion. Did that for a little while. We sold it, I think, in 2015. I realized along the way that running an exchange is not really what I want to do. I'm more sort of technology oriented and less whatever. Like basically everything about running an exchange is they're not technology problems. And then have been bouncing around the industry doing all kinds of things. 2018, I started a company called Equilibrium, which is now called Equilibrium Group, and it's actually the company that Gevulot spun out from. Equilibrium focuses on low-level protocol development, so it essentially works with a lot of the big foundations and companies, things like Starknet, Alio, zkSync, Celestia, all kinds of projects. Throughout the years, we've worked with most of the big names, and so we work on like the reason we started it was that back then in like 2017, 2018, the expertise of how to build a blockchain did not sort of exist in great quantity. And so our thinking was that we would build like an independent team that had that expertise. And that's kind of how it's played out. So we work on kind of what we would maybe call core infrastructure in all these projects. That can be, implementing full nodes, networking stacks, consensus implementations, VMs, compilers, whatever, stuff like that. And yeah, so I mean, relating to ZK or zero knowledge proofs, ZKPs, obviously we worked with a lot of projects that utilize them. So we worked with a lot of the different rollups. We've done a lot of work with privacy related projects like Alio and Zcash, and we've invested in a couple as well, like Elusive. And they like utilize ZKPs in this very like I guess practical way, like the way that makes sense from the term zero knowledge proof, wherein you gain privacy guarantees by generating zero knowledge proofs. But then we also work with all those different rollups and things where it's actually not so much a privacy thing. So that we've just been very involved in a lot of different things that utilize zero knowledge proofs in some ways. And then Gevulot kind of like spawned out of that. Mainly it stemmed from us realizing that no one was really thinking about how to decentralize proving, and we saw that as like a potential issue. So a year and something ago, when we were talking to these different roll-up teams, we just noticed that they were all sort of starting to think about how to decentralize sequencing, and no one was thinking about proving. And I think proving is more susceptible to centralization, just given sort of the sheer amount of compute needed to do it. And so we thought we'd take a stab at it, and then here we are.
So was it a case that you and the founding team at Gevulot just saw the problem and wanted to solve it, or was it a case that when you were working at the Equilibrium Group, you suddenly, amongst the other different sectors or spaces within blockchain, I guess you were just particularly interested in ZK and were desperate to move more significantly into that space? Or yeah, I guess why was the reason for spinning out Gevulot, apart from what you just mentioned?
It's so okay. Well, like we have a pretty strong thesis around ZK in Equilibrium Group. I think like the abbreviated version of it is that it seems like there's kind of two paths that the blockchain industry is on that are not mutually exclusive, but somewhat incompatible. There's kind of like the super fast global state machine path, which is like the Solana, Sui, Aptos type projects of the world, where they want to do kind of like get as close to the boundaries of physics on a single shard as possible, and have like the fastest possible global sync time. So if something happens in New York, how quickly does someone else know in Tokyo? That creates a lot of constraints around around like the compute and storage. So like you can only do very like small things if you want to do them maximally fast consistently. And then there's sort of like the other path is sort of the ZK path, which is the I guess you could think about it as like sort of almost infinite capacity. Like you could have like these very expressive big programs, and they're all verified on chain, and it's very flexible in terms of like what you can do and so on. And so given that thesis, like we are excited about both, but we did feel like there's, I don't know how, like there's like the super fast global state machine side of things is like pretty well covered. Like I think the design space is limited. There's not that much like innovation that's going to happen below the application layer there. But on the ZK side is like free range, right? Like there's a whole bunch of people doing all kinds of things, but it's much less mature. It's much less clear like what the structures are going to be. And so I think you can just have kind of more impact in shaping the direction on that side. And there were also just clearly things missing. Like people might be familiar with the term the modular stack, which is essentially like it's like the pieces that make up a rollup. Usually it's defined as verification and settlement, which is like Ethereum, you verify the zero knowledge proof on Ethereum, and that sort of settles you get finality on the things that happened in the rollup. Sequencing, proving, and DA. DA being data availability. And if you look at any of these categories, like back when we announced Gevulot, I don't know, like September last year or something like that. And back then, like there were already 5 data availability layers at least, like, and there's a couple of shared sequencers and so on and so on. But there's just almost nothing on the proving side of that. So that it just seemed to like a clear kind of area to try to figure out, does it make sense? But I think the actual process of coming to what Gevulot was today, which much more sort of like we just thought we'd see if we can come up with something that makes sense for rollup specifically, and then kind of like the structure of Gevulot, but also like the market structure emerged once we started to understand the constraints and the opportunities.
And I mean, you touched upon a little bit already, but a little bit about Gevulot and gave us a brief intro. But do you want to dive a little bit deeper into what it is you've been working on over the last 6 months since you launched, and probably a bit longer for that?
Yeah, so we've been working on it in some shape or form for over a year. But last year it was spun out, and now it has a dedicated team and so on. But Gevulot is a decentralized proving layer. So the The easiest way to understand it is basically what I just described, which is like a part of the modular stack. That doesn't quite cover it though, because zero knowledge proving is used in other things as well. So rollups are kind of one use case. And there's also coprocessors, ZK bridges, ZKML, ZKFHE. Like there's a whole bunch of different things. And the vision behind Gevulot is we want to be able to serve all of those use cases. So the whole kind of core of the idea is we want to drive down the costs of proving by aggregating as much of the different workloads from across different use cases and different areas of the industry into the same place. So by doing that, we get to basically utilize the underlying hardware better and then make everything cheaper. So you can imagine just like if you can buy a bigger machine and amortize it over more things, you kind of like start getting these mini economies of scale that hopefully one day grow to sort of real economies of scale. And so that's kind of like what it is. Another way to think about it is just as a decentralized kind of hardware coordination layer, or a decentralized cloud. It just so happens like you can run any program in Gevulot. We call them provers, but it could be a Mario game. But if it doesn't generate a proof, then it's just not very useful because you don't get the guarantee that the program was executed correctly. So it has these sort of facets to it, but I think the easiest way to think about it is it's a network of computers that generate zero knowledge proofs or like do computation that is provable is maybe the right way to think about it.
Yeah, and you mentioned there about decentralized proving. Are you able to share maybe to quickly whiz through what decentralized proving is, what centralized proving is, and I guess obviously you're going to or you're going to tell us about the benefits of maybe decentralized proving, but yeah, maybe just the differences between the two and why there's a need, or you feel there's a need for decentralized proving.
Yeah, so I mean the distinction is relatively simple. So centralized proving is company X runs a prover in AWS or something like that. So and decentralized, on the other hand, is there are many people who are doing some task, and that task can, or our definition is basically that there are many people that could do a task, and and more people can join permissionlessly. So you have this like censorship resistance or permissionlessness, I guess, to getting whatever task you want done. I guess it's important maybe to outline the state of the industry today. So like almost 100% of projects which utilize zero knowledge proofs in any way use a completely centralized prover. So usually the company behind the project is running a prover in AWS. And that's obviously fine for now, and like lets you get started. And then once that proof is verified on Ethereum, assuming there's no bugs in the verification code, or then you do sort of like still get a better guarantee than if you weren't doing that. The problem with that long term is that like even if the organization running the prover can't take anyone's money, they can basically hold the whole network hostage. Like they can just shut it down. They may not have an incentive to shut it down, but a government might, or some, for any reason, anyone. Like we've gone through this sort of like conversation many times in the blockchain industry, but ultimately I think whenever there's a point of corruption, maybe you could call it, someone tries to abuse it. And this is a very clear one. The other issue is that at some scale, it just becomes impossible for anyone else to take over. So like if you think about like the emergence of, I don't know, like AWS and Google Cloud and Microsoft Azure. So like at that scale, if AWS turns off, there's no one else who can even do that, right? Like no one else has that much compute to just suddenly take over all of AWS's things. And so even there are some proposals which are like, we can let it be centralized, but then we just have this kind of like, if something happens, then someone else takes over. I don't think that works either. And it's kind of unnecessary because it's not like impossible to build decentralized things regarding this that make sense. So that's kind of the issue. The decentralized structure that we think makes the most sense is like this system where, first of all, like in order to serve all use cases, we have like a concept of deployment. So users can deploy any prover they want. That's sort of distributed to the prover nodes. So we have something called a prover set. And those prover nodes have that program. So any one of them at any time can complete your workload. And when you want to do a workload, you create a transaction that gets allocated randomly to one prover that generates your proof for you. And then we sort of build economic and liveness guarantees around that. So there's various guarantees around like making the prover do it as fast as possible. There's other guarantees around like what happens if they don't manage to do it, and so on. So we kind of take this approach where we always have an elegant fallback. So if you fail, then every prover node competes to generate the proof for you on time, and so that's where sort of the liveness guarantees come from. So relating to the centralized structures, the point of all this is to allow kind of like a much greater diversity of provers to emerge. So we don't want 3 centralized provers. We want, hundreds or thousands. And in that way, we avoid most of the issues relating to centralized proving that I described.
Mm-hmm. A lot of what you described there and mentioned there comes back to, I guess, speed and performance and efficiency, which is, seems to be a massive part of the conversation that I speak with anyone sort of within zero knowledge at the moment. A lot of the work you're doing is in relation to hardware. So we spoke a little bit off air beforehand, but I guess that's a wider conversation. But how are you utilizing hardware to sort of benefit performance? And that might be a broad question. I'm sure that could take us in any direction. But yeah, we mentioned a team at sort of Ingonyama or Olvatana are doing work in this sort of space. So yeah, how is hardware accelerating this?
Yeah. So, well, first of all, just to quickly, like, I think on the speed and efficiency, I don't think that is actually the biggest problem right now. I think the biggest problem is cost. And so really like what we're working on is how to dramatically bring down the cost without compromising performance, which is like slightly different than maximizing performance. In the last, I don't know, like a year ago or 2 years ago, performance was like the main thing that people were optimizing. And I mean, it remains very important today, but at the same time, oftentimes verification happens sometimes, like not like, you're not verifying in every block in Ethereum. You're verifying like, I don't know, once an hour or something like that, once every 10 minutes, whatever it is. And so the performance constraints are actually not that great because, Ethereum block times are pretty long and so on and so on. What's more, so yeah, so the cost is kind of like the bigger part of that issue, and how, as well as like how do we move costs that are currently on the verification side to the proving side. So stuff like aggregation proving that like Libra and Polygon and stuff are working on. But coming to the hardware, so right now most provers are CPU only. I think ZK Sync and Filecoin are like the main ones that have done GPU provers. I suspect that will start changing soon. Like we'll get more and more GPU provers. And then there's like a whole sort of future segment, which people are very excited about, which is essentially like ASICs and custom chips. So usually these are like, ASICs are like chips that do one mathematical operation, and that's why they're so efficient, because it's like the actual operation is built into the chip as opposed to programmed on top. Custom chips are sort of like in that direction, but they try to, or this is a very general statement, but like this is the approach that most are taking, where they try to give you a little bit of programmability on top of that, so that, you know, if like the algorithm changes a little bit, like I don't know, the StarkNet decides to change the size of the finite field, it doesn't make the entire set of hardware completely irrelevant. And so there's a lot of people working on those things, and then there's also FPGAs. But I think given that we're not very far from ASICs, like I think FPGAs are probably not going to get used very much. But it's worth like distinguishing the, like, there's this kind of innovation happening on the hardware side, and that's going to, you know, increase performance and so on. It's a little bit unclear what that will do to costs. It may in fact be more expensive, because like consumer grade GPUs, for example, like scale very well. They're not like the most energy efficient, but they're like relatively cheap compared to how much compute you get. And like it's going to take time to just get these into production. Like even though I think they're like, Justin Drake had a tweet where he had an ASIC, and it's like, yes, there might be one, but they're certainly not in any kind of volume, where, you know, the industry would be transitioning like immediately. But I think the impact over the sort of medium term is similar to Bitcoin mining, where like at some point CPU and GPU kind of like become irrelevant. In this case, I don't think that happens quite as quickly, because CPU and GPU are probably just going to be so much cheaper. Like you can access that compute so much easier. They exist, like everyone has a laptop with spare compute kind of thing. But surely, like for most high performance requirement use cases, they'll become a thing. And so I guess from the Gevulot perspective, we currently, or like we're launching our Devnet on March 25th. We currently support CPU and GPU, and then we have a structure which we're going to be publishing more information on, or a design which will sort of allow Gevulot to accommodate whatever hardware people want to use. And that doesn't require additional integration efforts from us. So that's kind of where we are in relation to that. I can't say too much more about our plans on that front, but that's broadly it. Did that make sense?
It did to me. Hopefully it does to the guests. I'm pretending that I know what you're going on about in some instances, but yeah, a lot of it always goes over my head, so you don't have to worry about making it make sense to me. But I thought what was interesting there, and something I was going to ask on the back of it, is yeah, you touched upon how hardware is ultimately going to evolve, and you know we might be dealing with CPUs now, but ASICs, FPGAs down the road. What challenges is that going to cause? Well, anyone within the zero knowledge space? Does it mean that you have to sort of evolve what you're doing from the, I don't know, from the software design side of things, or the sort of ZK implementation side of things as the hardware evolves?
I mean, certainly, I think everyone who's doing anything relating to ZK will want to take advantage of the new hardware. In some cases, that'll be easier. In some cases, that'll require more work. But I don't see there being huge challenges relating to kind of like support for new hardware or anything like that. That's just a matter of time. Like you just need it to be kind of mature enough. And in the case of some, custom chips, they need to build an entire software stack to like let people do anything with it. And so these things just take time. I think what is potentially interesting is what happens to market dynamics after that. So and what I mean by that is like in the Bitcoin mining space, for example, like the people that had the best ASICs, like the miners that had the best ASICs, they just like became massive, and then the other people did not. That doesn't apply quite the same way in the ZK space, because it's not solely a question of speed like it is in Bitcoin. It is also a question of cost. So they're going to be a little bit different, but it certainly will create some, like, I don't know what the word would be for it, but like there will be some people who have really like they have tons of ASICs and they're like very performant and so on, and then there will be others who don't, like, because especially in the beginning, production volumes will be limited. If there's a lot of money to be made mining something or doing proving for something with that hardware, usually what happens is the company that manufactures it realizes, why do we need to sell this? We can just use it ourselves. And it kind of goes from there. So I don't really know what's gonna happen with that. But I think it, like, well, there are probably almost 20 companies doing stuff in that direction. So I think it's going to be very competitive, and I think that's very helpful for these types of things. And the fact that cost is a core consideration means that like the custom stuff really only starts being sort of globally competitive across everything once they're at production volumes resembling NVIDIA or something. So I think there's a good amount of time to work through any issues that arise.
Cool. And I mean, one of the last things we wanted to touch upon was, I mean, you spoken about a lot of it already, but I like to try and get my head around things in the simplest ways possible. So ultimately, who is the end user, and what are the use cases for Gevulot? So we mentioned a little bit about roll-up, CKVMs, bridges, CK mining. So I know there's a sort of broad variety, but I guess you might want to touch upon those a little bit more detail, or is there an angle you're particularly aiming for, or is it the beauty of Gevulot that you'll go far and wide? So yeah, a little bit more about the use cases and yeah, anything around that.
Yeah. So I mean, we're mainly focused on rollups and co-processors, primarily just because like the commercial opportunity in those categories is the clearest, and they have like a very consistent need to generate proofs. Very enthusiastic to also support like other use cases. The dynamics of those industries are still a little bit unclear, but that includes ZK, bridging, ZKML, like working with Modulus Labs, they just announced that they'd zero knowledge proven a 1 billion parameter LLM model, or I don't even know if it's an LLM, but an ML model. So that's
Daniel
very exciting.
On a previous episode.
Yeah, they're great, and I think that's going to be like incredibly important in the future. I like it. In fact, that might be existential for humanity to have decentralized control mechanisms on ML models. But it like it's much more unclear what that market is going to look like, how many proofs they're going to need, what those runs are going to be. Like right now, they're doing these like huge proving runs sometimes, but like they don't, need it on a daily basis. So that's kind of like where we are. But of course, it's super generic. So we hope and expect people to also come up with all kinds of new things. So I think one of the most exciting things about bringing the cost structure down significantly is that you make like more use cases economically viable. And yeah, maybe it's worth saying we're also very focused on like aggregation proving. I put that into the co-processor bucket. But so for anyone who doesn't know, co-processors are basically delivering some off-chain computation or a proof of an off-chain computation to a smart contract. But aggregation proving is like a category I think is going to explode because on-chain verification costs are so high. And there's not really anything you can do about it. Like you can have slightly cheaper execution, but a lot of that cost is actually paying for the security of having, whatever 5,000 servers do the exact same thing. And so there's a very real limit to like how much cheaper you can make that without just compromising security. And most approaches to doing cheaper verification, quote unquote, are just compromising security. So what people are exploring and what I think is going to be a very big deal here in the coming years is just doing a lot of aggregation proving. Like if you don't have a super strict requirement on like time to finality, like if you have, let's say, 3 hours of time before you need to have something verified, that's plenty of time to like aggregate a whole bunch of proofs. And that requirement may not exist in every place. And like it's all, in theory, it would be nice to have instant finality on rollups, but we'll see. But in a lot of these different use cases, what you can do is then take a lot of different proofs and basically via recursive proving, you aggregate them into one proof. And that then is much cheaper to verify. So instead of, verifying 10 proofs, you verify one proof. And what it does in practice is it moves the cost structure from on-chain to or from verification to the proving side. And because proving isn't re-executed, it's a lot more efficient. So I think we'll see a lot of things in that direction. And we're working with most people working on that. But yeah, as kind of like a subcategory, I guess, of co-processors, that's an exciting one.
Once again, there it comes back to the cost issue, doesn't it? So I'll put you on the spot. You mentioned that we've seemingly, maybe not completely solved, but we've moved on from the sort of performance and efficiency issue. What happens when we solve the cost issue? What's the next challenge in ZK, or have we then completed it and it's and we're all good? Or what will come next? What do you envisage arising?
I think we'll have this constant, push and pull between cost and performance. So like once you bring costs down, then people start thinking, oh, it would be nice to do all this stuff we can now do in a more real-time way or something like that. And then, and so I don't think it's similar to anything in computing. I think like you constantly want to bring costs down and performance up. And yeah, I mean, and in this case especially, it makes sense because that directly impacts the end user cost. It directly impacts the cost structure of the company if they're paying for the proving, etc. So they're very price or cost sensitive. One thing that it will one thing that bringing costs down will very immediately make possible is for a greater universe of organizations or projects to spin up their own app rollup or L3 or L2 or whatever. Um, right now, like one interesting dynamic of the roll-up side of things is that the cost structure of proving is essentially the same whether you are a zk sync or like some tiny project that wants to spin up your own roll-up.
Mhm.
And it's like in the ballpark of 1 to 2 million a year for proving alone, and then there's like verification is like 3 times that or something like that. And so that's just like not viable for most
Yeah.
small projects. And again, on the verification side, you can't do that much like on the cost structure besides aggregation proving, but I think that will help a lot. And then on the proving side, you just need to bring like the real cost of compute down.
Mhm.
That's a little bit easier. Like it's easier to do right now than it will be in the future, because a lot of these provers are being run on AWS, and AWS is very expensive.
Yeah.
So it's sort of like AWS is margin, and anyone can go look at the annual report of Amazon and see that there is plenty of margin. Is essentially like the opportunity for other people to do it cheaper.
Yeah. And once again, obviously, you're touching upon loads of different use cases. You're in a fortunate position where I'm sure you're close to an awful lot of those. But you mentioned aggregation. Is there anything else you see on the horizon as a massive growth area, or maybe who knows if you had your time again? Is there a particular area you would explore, or what's the next exciting ZK use case that you think we should be keeping our eyes out for?
Well, there's a lot that I get excited about, but they may not be exciting to other people. um, so a couple off the top of my head, like one is pretty obvious, is just privacy. Not just privacy networks, but like privacy, sort of private computation networks like Aztec and Alio are very exciting. They're pretty close to being available now, and that's going
Yeah.
to be cool. I think just as a quick side note on the privacy side of things, I think within privacy use cases, it's incredibly important to be very cheap. It is in fact a regulatory defense strategy to be very cheap, because if your privacy system is very expensive to use, who has like the biggest incentive to pay a lot of money for privacy? It's generally like criminals or other shitty actors. Normal people do as well. I'm just saying that like if privacy is incredibly cheap and people use it sort of almost by default, then it's much harder to argue that like your whatever thing is only used by bad actors. And I think this is like one of the most important fights that we're heading into, or like another one is just like how do we get kind of like privacy back? Like we had sort of like have privacy in the traditional world, then we had blockchains, we kind of lost our privacy, and then got other things like censorship resistance and permissionlessness, and then we want our privacy again, but when combined with censorship resistance and permissionlessness, is quite scary to a lot of people. And so I think that's like a very delicate thing that we need to figure out, and is going to be super important. Um, what else? Other things. I'm really interested in the general area of roll-up abstraction, or roll-up interoperability, whatever you want to call it. Um, the the general, I think like the user experience of rollups is atrocious right now, and we need to do something about it. I'm not exactly sure what that something should be. Like the Ethereum Foundation thinks that we should have one massive shared sequencer that like can do stuff atomically across rollups, and have like uh, what's the term, like unified liquidity across those things. There's like the nil foundation approach, which is like let's have some kind of shared state, um, which I think the ZK sharding thing, which I think is really exciting, and I think that's there's a fairly high chance that can work well. Then there's some other approaches, even which are, yeah, they're kind of all in that direction. Is trying to figure out like where should state live, like at what point of the stack should we figure out abstraction. But whatever the outcome ends up being, I think that's going to be one of the more interesting things, at least as an investor, to look at, because if we don't solve this, MetaMask drop downs, we'll just have like a billion different networks, and no one will ever use anything.
Yeah. Well, going back quickly, I mean, you touched upon privacy, and it's quite an interesting one because I guess, I mean, I went to a ZK hack meetup in London the other day, and one of the questions that Anna Rose posed to Zach from Aztec was, has ZK basically forgotten about or moved away from privacy? Because obviously that's where it all began, really. It was a privacy solution, and now, you know, there aren't many traditional sort of ZK use cases that are focusing on privacy now, are there? And I'm sure that could be a very lengthy debate from another time, and I won't ask you to put your opinion across, but yeah, it seems that it's almost a little bit forgotten, isn't it? The sort of the way that ZK can be used for privacy.
Yeah, I mean, I'm very biased. So at Equilibrium Group, we worked with Alio for a long time. We worked with Zcash. We've done a lot of privacy stuff. I don't think it's been forgotten, but like, so in the Gevulot context, we also work quite closely with the Aztec team, and I will say that like Alio and Aztec, like what they're building and what they're trying to launch, these are some of the most complicated systems ever built and launched. Like it's they're like almost rocket ships kind of stuff, where there's like 3 people who sort of like can even make some small aspects of the systems work. And so I mean, I think that's a big part of it, right? Like it's just like it's really not easy. And so you wouldn't expect everyone to do it. Frankly, I think there's like quite a lot of privacy projects, considering how difficult a lot of it is. But I think we also don't want too many, because like at the same time, it's very exciting. We get all kinds of like cool new programming paradigms and stuff. But no one yet knows what the use cases will be, because they also come with a lot of constraints. So a lot of things, like a lot of the sort of copy paste, stuff into a new EVM chain, like, okay, here's the Uniswap on EVM chain number 5. That doesn't work quite the same way with privacy networks. They're a lot more constrained, especially in how they read or touch like the same state. So yeah, I don't know. I don't think we've forgotten. But there's like a combination of difficulty, kind of like regulatory pressure or risk. I mean, the Tornado devs situation right now is like probably not attracting masses more people to doing that kind of thing. And yeah, so this was a non-answer, but like I
it's
think
interesting to hear your thoughts as well.
It's broadly where I would expect it to be.
Yeah, cool. And before I let you go, what's next for Gevulot? What have we got to look forward to from you and the team?
Well, I mean, the immediate thing is the Devnet launch on Monday. So this is Monday 25th. I don't know when the podcast is coming out, but it may
might
already
have just
be
gone
out
by then.
Yeah. So if it is in fact already live, then you should immediately go and check it out. The Devnet is essentially like a permissioned version of the system. So you can deploy any prover, you can generate proofs, verify proofs, they get stored, etc. It is permissioned, so you need to do a key. You need to register a key and be added to the allow list to take part. But it's also free. So we're kind of testing out the majority of the proving pipeline, I guess. And we're going to be running this. We're not 100% sure yet, but probably for quite a while. There's a lot of projects that are doing kind of continuous integration testing. There's a lot of projects which have sort of pretty sporadic proving needs, and so we want to be around when they actually do need to do something. And then we just want to let people start exploring different things that they could do with the system. It's going to be probably a lot more flexible than people realize. But yeah, so check that out if you are interested, and register a key. You can come play around. We'll have some like nice examples for how to deploy some provers and create some workloads.
Cool. And you and the team, I assume, will be in Athens next month as well. If people should come say hi.
Yeah, almost the whole team will be in Athens at ZK Summit and ZK Accelerate. We, I think, have a booth at ZK Accelerate. So if you're there, come and say hi. And then I think we'll also have someone in ZK Barcelona, which is like a week after.
Well, check out the Devnet. Go and say hi at those different events, and I'm sure the team will be more than happy to help you out. But yeah, that's all from me. That's all I wanted to touch upon. So I appreciate your time. Thank you very much for joining me. And if you haven't got any other parting gifts, I'll leave you be, and we'll speak soon.
Thanks a lot. This was fun. Let's do it again sometime.
I'm keen for that. Cheers, Teemu.
All right.
Bye.